Hey guys, today we're going to talk about more about arrays and specifically a concept called references and how references compare to values. So the first thing to think about with references versus values is objects versus primitives. Okay, so I think everyone remembers objects, right? So examples of objects would be string s equals raza. Another object we've worked with is arrays, right? All objects are arrays. All arrays are objects, sorry. So new int 3. We can make another object which is nums2, and that's 10, 11, 12. So those are objects, and then primitives, n equals 3, boolean b equals false, right? So that's objects versus primitives. Those are examples of objects, 3 examples of objects, and a few examples of primitives. With references versus values, it's all about how Java stores. How does Java store objects? How does Java store primitives? So one way to think about this is kind of like a memory table. So let me see if I can, pull up a spreadsheet. So let's focus on two types. Let's focus on a integer array. So int nums2 equals 1, there was 10, 11, 12. And then let's think about int n equals 3. Okay? So Java memory. So we're going to make a table, and the first column is going to be memory address. Or you could even think of it as memory location, might be an easier way to think about it. And then variable name, and then value. So let's talk about, let's put these in the other order. So memory location, this number doesn't really matter. I'm just going to use 1001. The variable name is n, and the value of n is going to be 3. Okay, so this is a primitive. This is an object, and this is stored by value. Okay, and what stored by value means is that the value is 3. It's directly next to the variable name. And that's different from how Java stores objects. Okay, so at the next memory location, we have the next variable, which is nums2, right? And the value is not actually going to be, so it's a little bit hard, right? Java wants to just stick a 3 here, like a single number, really. And how do you fit 10, 11, 12 into one space? You don't. So what Java does is it finds new locations, and it says, I'm going to put 10 here, I'm going to put 11 here, and I'm going to put 12 here, right? Because you're putting a single number in each value. So then the question becomes, what does nums2? What is the value of nums2? Well, nums2 needs to know how to get to 10, 11, and 12, right? It needs to know the location of 10, 11, and 12, so that when you write, if you were to write nums1, how does Java know to get to 11, right? So what nums2, the value of nums2 is actually the memory location of the first element of the array. Okay, does everyone see that? Nums2 doesn't hold 10, 11, 12. Nums2 holds a location of 10. And then from 10, Java knows that the very next location is going to be 11, and the very next location is going to hold the third element of the array. So if you were to declare a bigger array with like 100 elements, then there'd be 100 memory locations all in a row which would have all the space necessary for all of the values of your array. This concept right here is called, you can think of it as stored by reference. And the reason that is because nums2 is a reference to the data of 10, 11, 12. nums2 doesn't hold the data directly. There's no 10, 11, 12 right here. It's only a reference to the data, or where the data starts, really. 3 is the value. 1003 is the reference to where the object data begins. So that's the difference between values and references, okay? So when you're thinking about this as you're writing code, these specific numbers don't matter. What matters is that nums2 is just a reference to where the data begins, and n is the actual value. So does everyone see that? N equals 3. 3 is stored right next to n. Nums equals this array. The array values are stored later in a different location, and nums2 just has a reference to what that location is. So there's kind of different ways of drawing what this looks like, so ignore that. One way to look at it, which is pretty simple, is like this. Okay, so we have n, oops. Sorry, let me try to get this program working the way I want it to. Cool. Alright, so we had n, let me write the whole thing, int n equals 3, and then we had int array nums2 equals 10, 11, and 12. So one way to draw this out, which is a little bit simpler than the table, is you have n, and the value of n in memory is 3. And then you have nums2, and the value, as we said earlier, it is a reference to where the object data begins. So the object data is over here. Object data is at a different location, and it's going to be 3 blocks right next to each other. Okay, and so the data is going to be 10, 11, and 12. And then nums2 is just a reference, like an arrow. Okay, so this is like the reference. Okay, so this is the difference between store by value versus reference. With primitives, we store the value. With objects, we store a reference. And the data is elsewhere. The object data is elsewhere. In the primitives, the primitive data is right there. Primitive data. Okay, so let's look at what this means for you in terms of coding. So the reason this is important is because we can do things like int nums3 equals this array. We can do int nums4 equals another array, and this should be array. And then we can say int nums5 equals nums4. Okay, so let's do a little exercise where we print out arrays .toString of nums3, 4, and 5. Okay, so let's try to guess what's going to happen. So we're going to print out nums3, so that's going to do 10, 11, 12. We're going to print out nums4, which is 20, 21, and 22. And then we're going to print out nums5, which is the same as nums4. So it's going to do 20, 21, 22. Okay? So that's what we expect. And that's what we get. We get 10, 11, 12, 20, 21, 22, 20, 21, 22. Okay, so here's where references come in. So what happens if we say nums5 at 1 equals 1000? Okay, so take a minute to think about it. Nums3 is going to do the same thing as before, 10, 11, 12. Nums4, here's the question, is nums4 still 20, 21, 22? Or is nums4 going to be changed because of this line? And then nums5 we know for sure is going to be 20, 1000, 22. So let's run this code and see what happens. Okay. So the first line we expect because nums3 is never changed. The last line we expected because we said nums5 at the index 1, which is the middle, is 1000. So the interesting part is that nums4 is also has the middle element changed from 21 to 1000. So why is that? So the reason is because of references. Okay, so nums4 and nums5 are both references to the exact same array. They're references to the same object data in memory. So let's look at our little picture, and this will make a little bit more sense. So I'm going to do a new slide. Okay, so alright, So let's see, let's go back to our code. We have nums4 and nums5. So int nums4 equals 20, 21, and 22. And then we say int nums5 equals num4. So what this is saying is, so nums4, and what is the value of num4? So, well, nums4 is an integer array, which is an object, which means the object data is stored somewhere else. Object data. (20, 21, 22). And then nums4 is just a reference to this object data. And it says nums5 is the same as nums4. So what this is saying is nums5 has the same reference. Okay? It's kind of similar to the Excel sheet where we had the memory location, so you could think of it like this. So we said, let me copy these two lines here. These two lines here. We said nums4 is going to have 20, 21, and 22, right? And we know that this is the object data, so it's stored in a different location than here. This is 1006. And then we said, okay, so let's finish nums4. Nums4 is going to refer to the first element of the array, which would be here. So when we say nums5 equals nums4, what we're saying is nums5 is the same as what's here. So we just kind of like copy paste. So nums5 is 1007. Memory location 1007. So it's like nums4 refers to 20, 21, and 22 because it basically goes here to here. And nums5 does the same thing, here to here, meaning nums5 points to 20, 21, 22, which kind of in a simplified way is this. So then back to the code, when we say nums5 at 1 equals 1000, what we're saying is nums5, find the index, the value here, and change this to 1000. And then when you print out nums4, you get 20, 1022. When you print out nums5, you get 20, 1022. 20, 1022. Okay, so that's why references are important to understand, because objects are stored by reference. So nums4 is a reference to this data, and then nums5 refers to the exact same data that nums4 refers to. So when you change nums5, when you change the second element of nums5, you're changing the second element of nums4 because they're referring to the same object data. So what else? Why else are references important? You could look at equality. So one thing we can do, so yeah, let's just move on. So equality. So if you had 1, 2, 3, num7 equals 1, 2, 3, and then you said if nums6 equals nums double equals num7, they are equal, else they are not equal. So take a few seconds to think about this. Are num6 and num7 equal, or are they not equal? So let's run the program, and it says they are not equal. So why is that? So when you do the double equals, what Java is saying is, are these referring to the same data? And actually, num6 and num7 are not. This is in one memory location, and this is in another memory location. So let's we can actually do that in our Excel sheet. So if we say so let's continue this. So we say nums6, and the data is 1, 2, 3, and num6 is the location of the first element, and then we say nums7 is right here, and then the data is actually stored in a new place, and num7 refers to the location of the first element. So first element is 1, location is 1016. So when you say is num6 equals to num7, no, they're not equal because they refer to different locations of the data. If you wanted to test if they have the same elements, then you would use the arrays class. So arrays.equals. So now if we run this code, they should be equal. They are equal. Okay. So equality, so it's like equals equals versus arrays.equals. For references, equals equals checks if it's the same object. For primitives, equals equals checks if it's the same value. Referring to the same object. Okay, and then a third reason why this matters is that passing references to methods. So if I declare a method, it doesn't return anything, but we're going to call it increment all. So what this is going to do is it's a for loop that goes through the array that it's passed in, and it just says add 1 to each element. right? Same thing as. So if I say increment all nums 7, and I print out num7 before and after, what do you think is going to happen? So num7 is 1, 2, and 3. We print it out. It's going to print 1, 2, and 3. Let me comment all the previous prints too to make it simpler. Alright, so we have num7, it's 1, 2, 3, we print it out, it's 1, 2, 3. Increment all says iterate through the array and change each element from whatever it is to whatever it is plus 1. So it's going to see the 1 and it's going to change it to 2, it's going to see the 2, change it to 3, it's going to see the 3 and change it to 4. In this array, whatever array is. So the question is this array referring to the same object data as num7? Meaning, when you add 1 to every element of the array, is it going to affect num7, or is it only going to affect ARR? Right? So if we run this code, we'll see what the answer is. Okay. So it looks like this method changed nums7, which is kind of a new concept because in the past we thought that we couldn't do things like this. So like let me give an example with a primitive, right? So int I or a equals 10, and then we say public static void increment, and it says int b, and it says b plus plus. System.out.println a increment a so we have a, then we print it out, we get 10, we increment a, we call increment on a. So is this going to print out 11? Let's see. Nope, it just prints out 10. So why is that? Why does this method not change a, but this method does change nums7? Okay? And the reason is because a is a primitive and num7 is a reference. Num7 is an object, and it refers to this data, and this refers to that exact same data. But this B is a different memory location from this A. So I think this will be a little bit easier to understand if we go back to the table. So let's delete some of this. Let's kind of start over. So let's start with nums7. Num7 has 1, 2, and 3. We know that num7 is an object, and meaning that 1, 2, and 3 are stored in a different location. And in this case, they happen to start at this location, so we put that here. Okay? And then let's look at this line right here. So increment all num7. Increment all has a variable called ARR. So let's look at that. So ARR is going to be set to the same thing as num7. So if num7 is 1002, then ARR is also going to be 1002, right? Just kind of like copy paste, copy it, paste it, boom. And then when we say ARR at 0, it's saying, hey, find the first element of ARR. So the first element is basically, boom, here. And then we increment this to 2. And then it says, go to the next element, which is at index 1. So go here and go one more. Okay, and add 1. And then the last I becomes 2 at the end, which means go from here to the last element, increment it, bam. And so that's why you get 2, 3, 4. Now let's look at this piece of code. So A is going to be 10. And then you print out A, it's going to be 10, and increment A. So we have a new variable B, right? So we put down B, and then B is going to be the same thing as A. So we kind of just copy it, right? Copy, paste, boom. And then it says B goes from B to whatever B is to one more. So it just says, okay, so here's B, let me add 1, 11, boom, done. And then you go back here and you print out A. Well, A hasn't changed because B was a brand new variable. So that's why A prints out 10 before and after the method call. But num7 prints out 2, 3, 4 after the method call because ARR referred to the same object data as num7. Does that kind of make sense? Do you guys see that? These are different. This is a num7 is a reference to the data at memory location 1002, 103, and 1004. ARR is also a reference to the data at memory location 1002, 3, and 4. A is a primitive with value 10. B is a primitive with value 11. And yeah, so that's basically why these method calls behave differently. Yeah, so I mean that basically covers the differences between references and values. Thanks for listening.